Hi, welcome to RAR Math. Today I'm doing a series of videos on parabolas. For this parabola, the first thing I'm going to note is the negative 2x means I have a frowny face. I sometimes like to give myself a key indicator so later I know what I'm doing, or I can tell if I've done something wrong. Okay, x-intercepts. Where I cross the x-axis happens when y is 0. So I take negative 2x squared minus 8x minus 6 and set it equal to 0. Well, I want to factor this to figure out what x values would be 0, but I need to factor out a negative 2. Because I have an equal sign, I don't need to factor it out. I can actually just divide 2 from both sides. That leaves, and sometimes I do the full side. This time I'm doing it term by term because if I'm factoring out a negative 2, I have to make sure all my signs get positive, and it's easier to see if I do that term by term. X squared plus 4x plus 3 equals 0. Well, this factors to be x plus 1 and x plus 3, two numbers that multiply to 3 and add to 4. So x is equal to negative 1 and negative 3. When I write my intercepts, because intercepts are points on a graph, I make sure to write them as an ordered pair. Negative 1, 0. Negative 3, 0. Okay, my y-intercept is when x is 0. If x is 0, we have f of x is the same as y. It's function notation. Basically, we're saying the function with the input of x. Kind of f of x is like saying that x and y got married and y is being called Mrs. X instead of y. They're the same thing. It's not multiplication. It's just a way to say, hey, this is a function and x is our input variable. That's it. All right, so f of x, f of 0. Y equals negative 2 times 0 squared minus 8 times 0 minus 6. I hesitate to write it like this. Make sure you cross off your 0 terms. Otherwise, the negative 2 and the negative 8 somehow end up in the final answer. They shouldn't. Y is equal to negative 6. So 0, negative 6 is my vertex. All right, sorry, it's my y-intercept. So I have negative 1, 0, negative 3, 0, and 0, negative 6. 1, 2, 3, 4, 5, 6. Okay. Axis of symmetry and vertex. To get my vertex, I am going to use x equaling negative b over 2a. It's part of the quadratic formula. It's the part without the plus or minus the square root. And the quadratic formula is just that. Axis of symmetry plus or minus what we need to add or subtract to get to our x-intercepts. So this will be our axis of symmetry, and this is what we're subtracting, and this is what we're adding. So negative b over 2a, x equals negative of negative 8 over 2 times negative 2. Notice I'm coming back to my original equation. That's going to be 8 over negative 4 or negative 2. I guess I just drew it in there because the axis of symmetry needs to split our points. But it's nice to know that they both came out the same. If one of them came out different, I would know that there's something wrong in my work. So my vertex is negative 2 something. My axis of symmetry is x equaling negative 2. Just like the ordered pairs, the axis of symmetry is in a line. So we have to write it as an equation. The reflection point is reflecting the y-intercept to give us a fifth point to graph. So if we're going 2 to the right, we need to go 2 to the left. That's 1, 2, 3, 4, negative 6, negative 4, negative 6. Vertex, we got to finish that. To get the rest of our vertex, basically we figure out f of negative 2. We put in negative 2 for our x values to figure out the y value. Negative 2 times negative 2 squared minus 8 times negative 2. This is tricky. There are a lot of negatives going on. Okay. We start with the exponent. We just start with negative 2 squared. Negative 2 squared is a 4. All right. This is really negative minus 8 times negative 2. That's going to be a negative 16. This is going to be negative 2 times 4 is negative 8. Minus a negative becomes plus a positive. Joining forces for good. So we're going to end up with 8 minus 6, which is equal to 2. It's good that it's positive because if we follow the path, it should be positive. So negative 2, 2 becomes our vertex. We have 5 points. It seems like more than enough to graph our parabola. which is, of course, an upside down smile. It's a little frowny face. The domain of a parabola, as long as you're in math world, is all real. The range starts at the vertex and goes down. So it's headed towards negative infinity, and the vertex ends at 2. So the largest point, the largest value for y is 2. 2 on down. Nothing above 2 is actually being represented in our graph. That's how we figure out our range. If we read our graph from left to right, our eyes travel up to the top of the hill and then down, which means we are increasing from negative infinity to negative 2, and we're decreasing from negative 2 to infinity. A few pointers. Our range has a bracket because 2 is part of the graph. 2 is an actual value, so we use a bracket to indicate that it's an actual value. For the increasing and decreasing, we use parentheses because though negative 2 is where the increase ends, when we're at negative 2, we're at a plateau. We are neither going up nor down. So we use parentheses to say where it ends, but that negative 2 is not part of it. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.